Okay, so let's talk a little more about transformations, a couple more little rules or how they work. So just a little summary about stretches and shrinks. So when they're happening to the function, that would look like something like f of x equals a times the function. So a times in the case that we just did, x squared, right? Whatever that function is. That a value is being multiplied by x squared, and that's what makes it a vertical or a to the function of happening to the y values. Okay, because it is just multiplied by the whole function of x squared. If a is greater than 1, then that is a stretch. Okay, and if it's happening to the function, this is vertical. Just maybe you want to write that down, could be confusing later. So if a is greater than 1, that's a stretch. We had that up above, we had that in 3x squared. And if a is between 0 and 1, then that is a shrink. Okay. A really won't be negative because that will be that vertical reflection that we'll take care of separately. But if A is like a fraction or 0.5 or something like that, that is going to shrink the function. And then for the input, if it's happening to the x, that actually we didn't see above. Okay, that would look something like parentheses A times x end parentheses squared. So notice that it's happening to the x rather than to the entire function. So if in this case, if a is greater than 1, well, we have to undo what happens to x. So that is going to be a shrink. The function horizontally is going to shrink. And if a is between 0 and 1, then that is where we're going to get a stretch. And again, this is happening, this is the horizontal side of things. And what you're going to find with horizontal is it's always kind of the opposite of what you expect. I always think of it as like solving for x, so you have to undo what happens to x. Okay, let's do an example of each. So we could do, let's see, actually, maybe we should just do 2 horizontal examples because right above in the last video, I have proof here somewhere, we just did 2 verticals, right? We did the vertical stretch and the vertical shrink. So we haven't seen the horizontal. So let's just do some horizontal information now, okay? So this is going to be, let's do f of x is equal to parentheses 2x parentheses squared, okay? And then this one, we will make f of x equal to parentheses 1/3 x parentheses squared, okay? So these are both going to be horizontal because they're happening in the parentheses. But this one, since it's a is greater than 1, this is a shrink. This is a horizontal shrink by 1/2. We're going to multiply every x times 1/2. I know it says 2, but remember, we want to think of undoing what happens to x, so it would be dividing by 2. Okay, so let's do that. Remember, we're going to still make that nice little chart to help us. So we have 0, 0. Oh, that's not where we start the chart, is it? Let's do it the same way every time for ease. So negative 1, 1, 0, 0, and 1, 1. Okay, we're multiplying all our x's by 1/2 this time. So this would be negative 1/2, comma 1. This would remain 0, 0, and this would be 1/2, comma 1. So when we graph that, we see it is going to maybe look like it's taller, but it's actually just skinnier, right? It is a shrink in the horizontal direction. So it's more narrow than it was, okay? Now for the f of x is 1/3 x squared. This is also horizontal because it's happening in the parentheses, but it is a stretch because to undo what's happening to x, you would multiply by 3, right, to get that out of that parentheses. So this would be x times 3. Oh, this was a horizontal stretch by 3. Okay, so in our little chart, let's do -1, 1, 0, 0, 1, 1. We're going to multiply all our x's by 3. So -3, 1, remain 0, 0, and then 3, 1. And then when we graph it, here, you can think of this as horizontally stretching or as just getting fatter there, okay?